There is a silence in space that no human being has survived to describe properly.
And if you are out there, without protection, without a shield, without the magnetic field you've never seen but always depended on, you wouldn't die of cold. You would die of pressure.
In 2023, NASA's Curiosity rover measured the radiation dose on the trip to Mars. About one.
Today you will understand why going to Mars, in the way the world imagines, may be physically impossible. Not due to a lack of technology,
but because the biggest obstacle is your own body. It is a biological challenge, and that one we still haven't solved.
To have a real sense of what we are talking about, we need scale.
The moon is, on average, 384,000 kilometers from Earth.
The Apollo missions took approximately 3 days to get there.
The journey to Mars, with current chemical propulsion technology, takes between 7 and 9 months.
7 to 9 months inside a capsule.
Outside the Earth's magnetic field, exposed to deep space.
And if something goes wrong during the mission?
The communication delay between Earth and Mars is 4 to 24 minutes one way.
If you send a distress message, the fastest possible response arrives 8 minutes later.
In the worst case scenario, 48 minutes.
you are absolutely alone. No real help. No immediate response.
There is a threat that you do not see, do not feel, do not hear.
And it is destroying you, cell by cell, every second you spend beyond the protection of Earth.
It is called galactic cosmic radiation.
High-energy particles, protons, neutrons, heavy ions, that travel close to the speed of light and pass through metal as if it didn't exist.
On the International Space Station, astronauts receive an average of 0.5 millisieverts per day.
In deep space, Turkarifer, on the way to Mars, the estimate is 1.3 millisieverts per day or more.
A complete mission of 960 days would expose astronauts to about 1.1 sieverts of total dose.
The career radiation limit that NASA sets for all its astronauts is 600 millisieverts. A single mission to Mars could exceed that limit.
In 2022, the highest scientific council in the United States recommended a universal limit of 600 millisieverts for all astronauts.
And it explicitly acknowledged missions to Mars will almost certainly need waivers, formal exceptions to the very safety limit.
Adding enough lead to protect the crew would make the ship too heavy to take off.
High-density polyethylene and boron compounds reduce exposure, but they don't eliminate it.
With 10 grams per square centimeter of aluminum shielding, which is already very heavy Hess, no NASA astronaut could complete a mission.
Science does not deny that this is possible to try. It simply points out the price.
While you travel, while you float, while you seem to be at peace, Provice,
your bones are being devoured from within.
In microgravity, the support bones, spine, pelvis, femur, no longer need to work to support your weight.
And the body, with brutal efficiency, begins to dismantle them.
On average, astronauts lose between 1% and 1.5% of bone density per month on missions of 4 to 6 months. The proximal femur, the hip bone, loses about 1.5% of its mass per month. In 6 months, that reaches 10%.
The rate of bone loss in microgravity is about 10 to 12 times greater than that of common osteoporosis in the elderly.
In 8 months of travel to Mars, just one way, an astronaut would arrive with bones that...
And worse, recovery is not guaranteed. Studies have shown that even 12 months after returning to Earth, the internal bone structure does not fully recover. The astronauts exercise for up to 2 hours a day. This reduces the loss. It doesn't eliminate it.
But there is something even more disturbing happening. Not in your bones, in your brain.
In microgravity, body fluids don't fall, they stay. And they migrate upwards, right? To the head, to the skull, to the eye socket.
The result is called Spaceflight-Associated Neuroocular Syndrome, SANS, and NASA classifies it as the main health risk.
The optic disc swells. The eyeball flattens at the back. The retina folds. Near vision deteriorates.
In some cases, the changes persist for years after returning to Earth.
23% of short mission pilots. 48% of astronauts on long missions to the ISS.
Recent studies indicate that between 70% and 75% of astronauts on long-duration missions exhibit some degree of SANS.
And what happens to SANS on Mars in 38% of Earth's gravity? We still don't know. There is no definitive answer.
The exact cause of SANS is still the subject of active scientific research. There is no established treatment.
There is no approved countermeasure for long-duration missions.
And we still haven't reached what awaits you upon landing.
You arrived after 8 months, with more fragile bones, with altered eyes, with a dose of radiation that has already exceeded the limits of your own agency.
And now you need to function on Mars.
The atmospheric pressure on the surface is approximately 0.6% of the Earth's sea level pressure.
Without a pressurized suit, your bodily fluids would boil almost instantly, not due to heat, but due to lack of pressure.
The average temperature on Mars is minus 60 degrees Celsius.
At night, in the polar regions, it can drop to minus 125 degrees Celsius.
How does the body respond to this? We still don't know for sure. The data is insufficient.
The Curiosity RAD sensor measured about 0.7 millisieverts per day on the Martian surface, comparable to the ISS.
Mars is not a second chance.
Mars is a second set of problems.
If you've made it this far, feel free to leave your comment. What would you do differently?
Here is what is most disturbing when you study real space exploration.
NASA knows all about this.
The ESA knows.
Fel ar feicr seconds, Alicia, penny they're in train.
That you're seeking one due and fake the victims at actual field time. The astronauts know.
And they plan to go anyway.
Not because the problem was solved, but because some human beings, in all eras, have accepted that certain missions are...
Even when that cost can be IR reversible.
This is not a planning failure. It is a conscious choice.
The same choice Magellan made when crossing oceans without maps.
The same one that the first test pilots made when they broke the sound barrier.
The same one that the Apollo astronauts accepted when the space race didn't know if it was possible to return.
Exploration has always cost something.
The question is, how much are we willing to pay?
And who will pay?
No date presented here says that humanity should not go to Mars. Science does not prohibit dreams.
But she demands honesty. Galactic cosmic radiation has no approved practical solution. The SANS syndrome affects most long-duration astronauts and has no established treatment.
NASA's own radiation safety limit may need to be suspended for the mission to take place. The real question was never, is it possible to go to Mars?
In the next documentary in this series, Habitable Exoplanets Pro.